Here in Chapter 5, we introduce the idea of discrete probability distributions. In fact, before we start talking about discrete probability distributions, we're considering a new concept when we're talking about probabilities. In this case, we're thinking of the random variable, and here we use the uppercase letter X to represent a random variable. And a random variable is just sort of like a function that can take on many different values, and the probability that it takes on a certain value is given by its probability distribution. And what they're saying here, a random variable X is a numerical measure of the outcome of a probability experiment. Right, so for instance, if we're performing an experiment, we have some numerical measurement as our outcome, and so this random variable takes on those various different values with some probability for each of those different values that it could take on. And we'll look at two different cases here. A discrete random variable will be either a finite number of values of the variable that can take, or something that's countable. In other words, something that will correspond with the whole numbers, or with the set of integers. And then on the other hand, if we're looking at continuous random variables, well, these are ones that can take on infinitely many values in an uncountable way. So we'll think about that later on in another section, but the concept will be an important one to think about. Let's look at the example below. In the first example, identify the random variable and sample space of the experiment of tossing a coin and counting the number of heads. So here our random variable X will just tell us the number of heads in a particular toss. And the sample space, we'll use little x, will be the possible values in this experiment for this particular random variable. When we toss the coin, either it's going to be a heads, in which case there's one head, or it'll be a tails, in which case there's 0 heads. So it'll take on the values either 0 or 1. And in the example to the right, here we're thinking about, with a continuous random variable, an experiment that measures the time between arrivals of cars at a drive-through. Well, in this case, our random variable t will represent the time between cars at a particular drive-through. And so here the sample space could really be any positive value for t, because here time, right, is considered a continuous piece of data, so it can take any value that's greater than 0, but not necessarily discrete values. So anyway, in this first section though, we're going to be focusing more on the discrete random variable and how to construct various probabilities that can be associated with a discrete random variable.